Okay. Hello. Welcome to the live stream. In the chat today, we have Alex.
Hey guys.
We have Christian, our newest team member.
Hi everyone.
We have Samuel.
Hey guys.
And we have me, Joshua. It's going to be a bit of an ad hoc one this week. I've been busy with a few things, so I've not had the chance to properly plan this out. It's a bit of a new idea we've had, so expect a lot of compiler errors, a lot of staring at code confusingly, and feel free to ask as many questions as you want about Rust and so on. Right. So what we're going to be implementing today is a system to intern tangle hash to make accessing transactions in the tangle faster. So the theory behind this is that a transaction is quite a heavyweight thing, right? It's 243 trips, I believe, which even when compressed as much as possible is still quite a lot of bytes. And you don't want to be trying to hash that and then try to look it up in a hash table because it's quite a large data type. So interning is a system by which you take complex data like a hash and you place it inside a sort of a data table that goes elsewhere, and then you use this table to give it a secondary index, a lot smaller and lightweight, easier to compare against things. So we're going to have a go at implementing this for the tangle.
Josh, one sec. I think we have a feedback group inside.
Oh, do we?
Yeah, in the chat. Some people.
That's bizarre. I've definitely muted myself, or rather muted the live stream.
Well, not for me.
That's a bit strange. Sound echo. I'm not hearing any of that. But then I wouldn't. I guess I'm not sure where it would be coming from if we did have that. Yeah, I'm not sure where that would be coming from. Is it still bad? Is it? Is that to being bad or it being fine? Everything's muted, so it's quite bizarre. Any improvement now?
Did you see what they brought?
Just going through my audio settings.
That's weird.
I can't find anything here that would be causing that. Everything's Everything's muted. It's good now? Okay, that's really quite bizarre. Fair enough, I've changed nothing. Right, well, time to continue, I guess. So what we're going to do here is when a transaction is placed inside the tangle, we're going to want to take its hash and we're going to want to intern it in this separate table, and then we'll want to replace references to that hash to the interned index that we created earlier. So as I say, this is going to be a bit ad hoc. I've planned this a little bit for maybe 10 minutes, but not a huge amount. So the first thing we're going to do is we're going to introduce a new dependency. This dependency is going to be lasso, which is a crate for interning things. Let's just check to make sure that the audio issue hasn't come back. There you go, that seems fine. Okay. So we're going to start to do this by creating a way to intern our hashes. So in this case, I'm going to create what's called a threaded rodeo, which seems to just be Lasso's internal name for a multi-threaded intern table. So I'm going to give it a particularly poor name at first, and I'll rename it later. So we need to import the dependency. Put it down here at first because it's not really related to the normal data structures in here yet. Okay, I think that should all be fine. So let's see if the compiler is happy with us adding this dependency. And as I say, feel free to ask any questions. It doesn't have to be strictly related to this. It can be about B in general, or just Rust stuff. So, okay, we probably need to import something that we imported wrong. A little bizarre. Yep, the correct version. You know things are going well. When you fail at the first hurdle, adding a new dependency. How bizarre. Anybody spot what I'm doing wrong?
Nope.
Lasso 0.3.
Maybe they removed Reddit Rodeo.
No, it doesn't look like it. It's right here in the root of the crate.
I think you need like to enable a feature to use thread rodeo, if I'm right.
Oh, that makes sense.
I'm not sure.
Yep, that's
Yeah,
true.
yeah.
I should have read the docs more carefully.
That makes sense.
There we go. Right. So we need to implement this trait for our hash. So this might be a bit of an interesting one because that's actually in a completely different crate, which is going to conflict with Rust's orphan rules. So I'm going to have to modify that crate. And that crate was recently moved to the main B repository, which makes this even more annoying. Right. Well, one thing I can do is I can use a wrapper type for now. That's probably a sort of okay way of doing things. And then we can change it later after the live stream, because I don't want to be running around through several different repositories trying to fix this. So actually, let's see what the requirements are. So okay, so the trait key has a few requirements. The first of which is it needs to be copy and equal. Makes sense because you want to be able to compare them. Thankfully, our hash is now it's copyable due to a few changes we added recently. Looking at the docs a bit further, it looks like we might actually be able to use one of the existing key types. Yeah, okay, let's do that. Let's do that instead. That's a much better idea. Okay. Right. So one of the requirements that Lasso has is that an intern type is expressible as a string, which might not be feasible for us. I mean, it is possible for us to express a hash as a string, but it's not a particularly efficient way of representing the data. So that might mean that Lasso is a suboptimal crate for solving this particular problem. So as an alternative, I'm currently going to resort to a crate that I've used for a lot longer and I find is generally a lot more reliable for things like this. Just get the latest version of it. Well, I did promise a bit of an ad hoc stream, and we're living up to that so far. So now we can remove this because ArcIntern provides this stuff internally. So now the important thing is we want our vertices to be addressable via an interned hash. So we're going to change the type that we index each of the maps with. And now we're going to get a lot of compiler errors when we try to build this. Just check to see if there are any questions.
Josh, in the children field, there is still a hash set of hash. Do you want to change that as well to ArcIntern?
Let me think about that for a moment. No, in this case, because we might not have interned the transaction into the in-memory tangle.
Okay.
So you only want to be interning things that you know are already in memory, because otherwise you can't look them up via the intern cache.
Okay.
So let me think about this. This might not be so easy to do with internment, actually, because we want independent control over when we free those data structures. We don't want to be holding that hash around in memory forever. This might actually require a custom solution. Let me think for one moment. Right, okay, I'm going to try for a custom way of doing this. So the problem we have is that we want to be able to manually control when we intern things and when we unintern things. So for example, later on, when the storage layer is completely developed, we're going to be wanting to be removing things from the in-memory tangle cache at will. And in the process, we're going to want to be invalidating old interned keys so that they need to be looked up again in the intern table. So I think the best way of doing that is probably a custom solution, since neither internment or Lasso are really built for doing that. So let's have a go at that. At least that'll be a little bit of a fun exercise. So let's create an interner module. Okay. Make sure we've reverted those changes, and we haven't. Okay. There we go. So for now, what I'm going to do is I'm just going to use a hash map to intern things. It's probably not the most efficient way of doing it. I think, for example, it might be possible to use some kind of an index map to do this, but getting that working correctly is a bit outside the scope of this live stream. So we can probably swap this out later on. But let's create such a hash map. We might want a dash map for this actually. It might be a bit faster in parallel than locking up the entire thing. So we're going to have our key that we'll use, the intern key, is going to be a U64, and this will be an always incrementing number, which can be unique, and so we don't have stale keys that get referred to older things in the intern table. Remove this requirement here and use it later on. Okay. Oh. What am I doing? So later on it might be nicer to replace this type def here with something that's closer to an opaque type, but this will do for now. Might change this K to a T, since it gets a bit confusing with key up here. Feel free to ask any questions as is usual. Otherwise the stream's going to be a bit quiet.
We just enjoy the sound of the keyboard.
So this data structure is meant to be immutable, so I'm using an atomic ID counter which will get incremented every time you intern a new item. Yeah, that's pretty much it, to be honest. So next we want to actually perform the interning of a new item. So check the dash map docs now. I think it has an entry API, but I want to just make sure it does.
Yeah, right. It does.
Yeah. so this is going to cause us a bit of a borrow checker error here. So I'm actually going to move this out into a closure of its own. Yeah, actually, no, that's not ideal. Right. There we go, that's a bit better. So hopefully this compiles now. I'm sure it won't for many reasons. What have I done here? Oh, whoops. Okay. I should have seen that coming. That's to be expected. Okay, right, so we have a way to intern things. To be honest, I'm not enthralled with this system because it requires parsing the item itself a lot when it should really be possible to parse only the hash reference. But we can deal with that later. That sort of an optimization isn't particularly needed right now and can be added later. So actually I am going to make this an opaque type. So we're using phantom data here to effectively convince Rust that this type parameter is meaningful in this type, even though it doesn't actually exist within this type. So the reason for this is that the ID, or rather the key, is going to be tied to the specific type that we're interning. So this just means that it's a little harder to mess things up, and the compiler can warn you if you're using the wrong key for the wrong kind of intern type. Let's just make it debug as well, we might as well. I'm sure it'll be useful. Right. Okay. I shouldn't have derived that. That wasn't a good idea. Okay, let's implement those things by hand. At the moment, we're just implementing a few traits that are common in the Rust ecosystem for this key type. And the reason for this is that the way derived macros work is that they automatically generate macros that take into account the type parameters. But because our type parameter is sort of a phantom type parameter, it doesn't actually appear within the type as a value. That means that the automatically generated implementations that Rust will create will be overly conservative, and they won't properly work with all of the type parameters that we want them to. I see questions or no, I'm not sure. Okay, right. And right is ironically the very macro I'm using right now. No, actually, I'm not going to do that. Right. Now I can get rid of these because we'd have conflicting implementations otherwise. Okay, and the compiler gods like us. So next thing to do is to start to implement this in the Tangle. Might rename this actually because it's a bit unclear as to what it is at the moment. Will do. Okay, compiler likes us again. So now what we're going to be doing is when we insert a new transaction, we're going to take its hash, we're going to intern its hash, and then from then on, we're going to address that transaction by its intern key. And this is a lot cheaper to do because the intern key is just 8 bytes. So it's a lot faster to compare and things like that. The word size on most modern architectures is also 8 bytes. So that means that it's usually just a single machine instruction to compare these values for equality. So here's the code that actually deals with for Tangle insertion. So what we're going to do is we're going to create an intern key if it doesn't already exist. I've not thought through exactly how we're going to do this, because there are two ways of doing it as far as I can see in my mind. We could proactively intern all hashes that we're aware of, or we could just intern hashes of transactions that already exist in the in-memory Tangle cache. I've yet to decide which of these is the best strategy in the long term. But I'm sure the best option will make itself known in time. This live stream is pretty much me just experimenting with interning and trying to see if it's a viable option for us to take. So I'm not treating this as like a final product at the moment. So
right. Just go with the simplest approach, I think.
Actually, I'm not going to call this internal get. It's a bit of a weird name because it implies we're fetching the hash, which we're not. Right. Okay. I'll have to think about whether we do the same for tips in a moment, but okay, so I think actually the best option is probably going to be to intern all hashes that we're aware of. Whether that will leave dangling hashes sort of, or rather unused hashes hanging around in the tangle, I'm not sure. We need to be careful about that, but that's probably something that we can think about in more detail later. So for now, I'm just going to treat every hash as an interned hash. So yeah, this is all okay. Okay, then of course we'd use the key to fetch rather than the hash itself. And of course, because it's a copyable value, there's no reason to pass it by reference, because it's the same size of a as a reference anyway, so that would just create an unnecessary dereference. It's a bit boring, but that's okay. Okay, and now let's see all of the compiler errors we get. I imagine quite a few. Yeah, as expected. So programming in Rust is fun and satisfying in some ways, but often you spend a lot of time just going through lists of compiler errors and fixing all of the things that you've broken and the compiler is pointing out you've done extremely, extremely wrong. Okay, so that's another thing we need to do.
Yeah, that's why it's a good thing
We
to
need to
compile very
implement.
often.
Yeah, exactly. It caches all. It catches all of the extremely poor decisions that we make as programmers.
Right.
Okay.
But I don't know, on the other part, it makes refactoring really easy because you can use, like, for example, if you do a change in your API, you just have to follow the error propagations until they disappear. And that's like a really cool thing.
Yeah, that is true. It is extremely helpful in that regard. It's pleasant to work with because you have sort of a confidence in your code when it's written. It's almost like working with like an automated proof assistant in a way, except perhaps a little bit of a weaker proof assistant.
Yeah, I don't know. When you do cargo build, you can be sure that if that thing compiles, you have like a certain degree of certainty that probably your code do what you want, and that you didn't miss any details in the middle.
That's right.
Right, so we will be there in a second. So, a few more things I've got to implement. Now you can test me on my ability to remember how to implement all of the common standard library traits. This is fun, writing lots of boilerplate code. I think that perhaps the deriving constraints are sort of the one thing that that I think needs a fair bit of improving with Rust, because when you derive a trait, it's derived at an AST level, and so the derive macro isn't really aware of the type system and whether it's actually necessary to constrain a certain type parameter in order to implement a trait. I'm not sure how other languages do it. The only other language that has deriving that I'm aware of is Haskell, and I don't know whether it works at a type level. I think it might, but then I think it might also only be permitted to derive certain built-in traits, whereas Rust can do a lot more than that with procedural macros. So yeah, I don't think I've got much to say there. But was it partial compare? No, it was partial equal, wasn't it? No, it was option bool. Let me check the docs again. I think it was option bool because it's meant to be able to account for things like floats that don't have total ordering. Oh, I've even got the name. Okay, no, it's not. Okay. No, I'm just getting confused between partial equal and partial ordering. Okay. think that's one error gone. No, it's not. One more. Okay. Right, this makes a lot more sense. So now its complaints are largely because of code in other modules. So I've not taken a look at the traversal code much, so let's hope I don't refactor this badly.
Let's see.
I'm sure I will completely mess it up, but let's give it a go. There's always git revert, right, and git hard reset.
Yeah.
Right. I'm going to get complaints because I've not taken some things by reference, or rather dereferenced some things. So, ooh, look at that. Look at that stream of errors. This is great, isn't it? I'm sure this is the content that the viewers signed up for. Lots and lots of errors.
Yeah.
Right. Um, 49. Okay, so here's the thing. I'm going to switch to this file. So our transaction has this trait implemented for it. So our transaction is just all of the data that comes with an IOTA transaction. It has this trait implemented for it, which gives you the trunk and branch of that transaction. But we don't actually want this hash. We want the hash or the interned key version of that hash. So we're actually going to need to cache this information somewhere. So I'm thinking we cache it on the vertex. That seems like the most logical place to go. Would you agree with that, Alex?
Yeah, probably. Sounds good.
So what I'm going to do here is I'm going to so the idea being that if we have an interned version of the trunk and branch hash available, we can use this to directly look things up, and if we don't, then we can always revert to the older version. So the best way to do this, I think, might be to I'm going to say create a new data type. I'll probably move this somewhere else in a bit. No, hash key I think makes most sense. It's going to be bound by a particular lifetime, which is the lifetime of the hash reference. I'm sorry if I'm making a lot of typos here. I actually managed to accidentally order myself a Dutch keyboard a few months ago, and I mostly touch type fine, so it's not really a problem, but occasionally when I'm trying to search for punctuation, I get the wrong key. And then the alternative is it intern key or intern key? I forget. Intern key. So this is our key that we can return from this function instead of the hash. We can use this to look things up. Yeah, I think I'm going to move this. Where to? That's the question. Probably its own file, to be honest. So Alex, one thing to consider here is that vertex is of course defined in a separate. Oh no, it's not a separate crate. I take it back.
Yeah.
I think I was looking at a different file when I said it was in a separate crate.
Oh, okay.
Right, let's create a new file for it.
Josh, please consider that there are only 6 minutes left.
Oh, yeah, that's fair enough. I mean, I don't think we're going to finish in the next 6 minutes, but hopefully this is a vaguely interesting introduction to how one might implement interning in a situation where you can't actually keep the intern keys around for as long as you want in some kind of arena like you would if you were, say writing a compiler and trying to intern a load of strings, because you actually want to evict these things from memory at some point. So it's probably going to need a fair bit of it's probably going to need a fair bit more design work until we have a thing that's actually functional. But for now, I hope this live stream was enough that people can have sort of a gist of where we're going with this. So one thing we're probably going to want for hash key in particular is we're going to want to be able to convert it from things like an intern key. So that's what I'm going to do. Are there any questions while I'm just completing this last bit?
Just comments.
I mean, I've got a lot of things wrong in this live stream. I started off by dragging in 2 different dependencies, which both ended up actually not doing the job that I thought they'd be doing in this case. So.
Yeah, well, I think it's okay, and the community sees that even at your level, things can become still quite difficult. So
yeah, I mean,
it's not something that you just write.
Here. And I think about this from time to time in that the compiler can sort of tend to guide you through things and make it feel like what you're doing is not as complex as it is. But then I sort of imagine trying to write this in C or C++, and quite frankly, it terrifies me. Because the experience of sort of writing Rust has taught me about all of the ways that ordinary code can go extremely, extremely wrong if you're not careful. Things like dangling pointers and race conditions and things like that. And I wouldn't at all feel confident writing this in something like C. But Rust gives us the power to sort of to go forth with confidence. How many years have I been writing Rust now? I picked up Rust for my degree thesis. I was sort of interested in it, and then I thought, oh, why don't I use this? And then kind of stupidly, I decided to write an OS kernel as my first project, as like my end of year project. So that was a bit of a baptism by fire. That was back 3 years ago now. So I guess sort of 2.5-ish years I've been properly writing Rust. But it's basically the only language I write ever now, so I have far too much practice. That was just to answer some things in the chat there.
Yeah, I think we have now 2 minutes left. I think we won't finish this during this live stream, but
oh no, that's for sure. But
at
the very least, we can kind of have a bit of a sample of where. And my Discord crashed again. I'm glad I had it open on another screen so I could see that. I swear it does this every single time I do a live stream. It just decides to crash about 40 minutes in. Can you hear me again? Am I in the chat again?
Yeah.
Okay,
Yeah.
great.
Yeah, we can hear you.
Yeah.
So yeah, last thing I'm just doing is just implementing for our hash reference now. So the idea is that we can use this hash key as a way to index the tangle without necessarily knowing the intern key. So we can optionally give it a hash key instead, or rather the hash itself instead. So this can be used as a way to look things up if you know a bit more information, or if you don't know much information and you only know the raw hash itself. I think that pretty much sums it up for now. There's still a lot, still quite a lot that's unfinished here, but our time is up now, so I hope you enjoyed it. Even if it was a bit ad hoc and kind of messy and things didn't really go to plan, but yeah.
I think it was still an interesting live stream. I mean, it's a big feature, so cannot expect it to be ready in 1 hour, right? so yeah.
No, I think quite honestly, it's gonna require maybe several live streams worth to get this kind of thing working well.
Yeah, right. But I think the basic idea came across, so yeah. It's a good thing to have.
Okay, well, thank you for joining us on this wild ride of compiler errors and going back on ourselves a lot.
Yeah, thank you guys for joining and watching. See you next time.
See you next week.
Yeah. Bye.